for that sequence. Don't let the negative throw you off. That's just where you start, right? AN. Well, I know what AN is. So where do you start?
Start at -2.
Start at -2, that's where you start.
Yes.
And then go up how many steps?
N-1
N-1 steps.
times.
And how big is each step?
7.
7.
7.
I love it. Now some of you guys might realize, can you clean that up a little bit? If you don't want to, you don't have to. But you could distribute the 7 through, right? Get your like terms together. So you could do that. Let's just not for right now. But you could do that, it's not a big deal.
That's too much.
What would A11 be then? What's A11? Do you see how now it's just plug and chug?
-2.
Does it make sense that our formula is based off of which term I want? That only makes sense. If I want the 88th term, I want to be able to plug 88 in somewhere and have it spit out that term to me. And it should make sense that it should be able to do that because I just keep adding 4. It's simple. You should be able to tell it to me. So what's A11? It'd be -2 plus 10. Don't go too far. 11 minus 1, 10 times 7. So it'll be 70 minus 2.
69.
68. Okay. 68. Get your mind. I didn't mean to set you up for anything, Ryan. You did that entirely on your own. So I'll let you guys handle the comments. Yeah. Tiff.
Thanks for the
Oh,
support.
for the first one, the n-1, that's just an equation, right?
Yes.
So you give us a number for that n?
Exactly. I've got to.
Okay. So like for the,
Now, do you notice? I will definitely ask you for.
-2.
What's up?
Okay, AN equal -2 plus n minus 1 times 7.
Beautiful.
So that's the end of that problem, and the new problem is now A11.
Yeah, so that's like number 1, I'll ask you what's AN. Number 2, I'll ask you what's the 11th term. Then you just got to plug an 11 in.
Okay, so we do -2 plus 11 minus 10 times 7,
Beautiful. So you just plug an 11 in.
70. Oh, minus 2, okay.
Beautiful. Okay. Yes, ma'am.
What is the A in the A11?
What's okay? What is this also known as?
Start.
A1,
Okay.
A2, A3, A4.
Okay.
Yeah. So AN,
Means anywhere on.
and this is what people hate about math, but you got to see the power of this. I want a function where somebody, if I want the 1000th one, but you want the 987th one, we should each be able to plug it in there. And the only way I could do that is to have a variable here, because I want to change it depending on what the hell I want, right? So if n is a number of years later, and this is how much money I'm going to have in a bank account or something, I want to know, well, if I leave it in there 10 years, or well, if I leave it in there 12 years, I want to be able to change it. I can only change it if I have a variable in there. Variable, right? I want it to be able to be varied.
And then why is for 10 it's just 10 and then for in it's
Because the next.
Oh, sorry. So, I mean, I kind of did it.
You skipped it.
N is 11 minus 1, and 11 minus 1 is 10.
Okay.
Okay, so that's my bad. I kind of skipped that, but that's where it came from. Just subtract 1 from it. What do we keep seeing now? What was -2? What was it also known as?
start.
So the, what is its technical official name? A1. I like that though. I like start, but its technical name is A1. So isn't this formula always going to be A1 plus something, A1 plus something? Because that's where I start, like you guys just told me. So AN is always going to be A1, whatever that is, plus n minus 1. And now we just need a symbol that represents this. And how did you guys get that this was 7? Because what's 12 minus 5? 19 minus 12. Difference. So that's why they use, and I use, the letter D for difference. So that'll be whatever the difference is. So now that equation works for any arithmetic sequence. If it's separated by the same number, adding, I can use that equation. Now I want you to realize, I mean, this is not the most ground-shaking, earth-shattering kind of example of this, but there's a really good reason why we have formulas, period. Because what we just said, I want to be able to change it. Yeah.
So for like you know how you put like for the first example 1, it's like they're gonna ask us what AN is.
Yes.
Do you want us to put AN and then put the distance, or actually put?
No, here, you gotta tell me what AN
No,
is.
like-
It would be this whole thing.
Okay, so you want us to put the 7
So what's
there, not the-
AN
not
in
the D?
general? A1 plus N minus 1 times D.
Yeah, so you want us
So
to put the formula?
specifically for this equation, for this sequence, what is it? A1 is negative 2, plus N minus 1 times the distance is 7,
Okay.
right?
Now, why isn't the D in parentheses?
It could be,
It doesn't have
but
to be though?
definitely not. I just want to, I mean, here I put it, I didn't put it and I did. What's it still signify no matter what?
Okay,
Yeah, so I don't need it in parentheses.
so if I
Just
see
don't
it
make
after
it that
parentheses, I'm gonna
complicated,
multiply.
each to this one.
I know, so.
Yep.
Yeah.
All right, guys, let's do one more example. Let's see. Let's do an example where it's going down. Let's see.
No, just leaving it alone.
Beautiful,
Oh,
right?
wow.
So watch what you can do for yourself. If the question is AN equals what? Guys,
A and N plus, N, well, would it be, N, since it was N minus, N plus 1 would be N minus 1? Would it be opposite of the other formula?
no. Formula still holds. So the formula is this. What do I need so I can fill in the formula? I need A1,
And
and I don't need N, because it's just AN, it's not specific.
I need this stairs.
I need A1, and I need
D.
D.
Always.
So, summarize for yourself, what is A1? 27. Now what's D?
19.
Negative 8. Because it's what I keep adding. Do I add 8 to get here?
minus.
No, I add negative 8 to get there, don't I? So if it's decreasing, this is going to have to be negative. The formula doesn't change. The formula does not care. As long as you keep adding the same thing, the formula is that way. So what's AN then?
9.
A1,
27,
27, plus N minus 1 times D,
which is negative 8.
negative 8. Now here, Archie, I definitely put that in parentheses, otherwise it looks like it's minusing 8. I want to be times negative 8, so I've got to put it in parentheses. You guys see that? You just have to plug and chug now. It's a formula. You can see what it needs. Sort of like, and I don't want to bring up any bad memories, but y equals mx plus b. If you know m, you know b, you don't just plug them in, right? I know some of you guys are like, we can witch in them. Don't mention lines, I'm dying. But it's just, I just need to find those and put them in. And now step 2 would be, specifically, what is a 51? Now that's easy as hell now. The semi-hard part, which is really not hard, was just getting the equation. How do I get A51?
Let's see, 51 over the,
27 plus,
50 minus 1.
yeah, 51 minus 1, 51 minus 1,
And the different minus 8.
times negative 8.
Negative 8.
So all we did was we plugged in the 51, right? You guys see that? So if I want n to become 51, I let n become 51. So now I get 27, and then you can figure that out.
We can do the shortcut, like if you say 850 or 828, 27 plus minus 1. I can do it straight, right? Like,
I'm not sure what you
instead
mean.
50, instead of 51 minus 1.
Oh yeah, no, I mean you could put 50 there, that's fine.
It's always going to be
It's always going to be minus this
yeah,
one. Yeah.
Minus the minus.
So you can go straight to here, that's fine. 27 minus 400, negative
I didn't get that far.
373, I love it. Let me show you one more thing. I see a lot of glances at the clock. Let me show you. This is kind of cool, actually. Of course, you know, I think everything I'm showing is cool, but this, I think you'll agree with me, it's kind of cool.
Yes, it's very cool.
I know right now you're like, yeah, prove it to me, math boy. Let's take a semi-easy sequence here. Actually, this is from there's an urban legend in math
I'm not gonna die.
Yeah, I know. I was just gonna say, you're not gonna die, but right, don't worry, I'm gonna pick you off one by one. Great. You're all gonna watch me now for signs of psychosis. The urban legend goes, there's a guy named Gauss. So if anybody's heard of a Gaussian curve maybe, or Gauss's law or anything. There's this guy Gauss, he did a stupid amount of mathematical and physics work.
You must have a long time.
The legend is when he was in like 4th grade, the equivalent of 4th or 5th grade, the class is driving the teacher's crazy. So the teacher said, okay, everybody sit down and I want you to add the numbers 1 through 100. Do it now. You know, he sat down, he's like, reading the paper, he's like, this will give me some little bit of time. And Gauss, 10 seconds later, comes up and says, here, teacher.
I remember that.
Here it is. Remember that?
I heard that.
Yeah, it was a good movie. And the teacher's like, what? And so he sits down and he adds them all up. 1 + 2 is 3, + 3 is 6, + 4 is 10. He adds them all up and goes, yeah, you got the right answer. How that, what? So this is the legend. We don't know if it's true or not because we didn't have video cameras and YouTube back then. But how the hell did he do it? So if you had to add them all up, you would think 1 + 2 is 3, + 3 is 6, + 4 is 10, + 5 is... That's going to take you a while, right? What Gauss realized is, does it really matter what order the numbers are in? So what's 1 + 100? What's 1 + 100?
101.
What's 2 + 99?
101.
101. What's 3 + 98? 101. How many of those pairs are you going to have?
99. 50.
So what he did was he did 50 pairs where each of the pairs have a sum of, and that's 50-50. Which is kind of neat by itself. The sum of 1 through 100 is 50-50. I like that. So what's the formula then? What the hell did we just do? So we're going to use this symbol, S sub n. Like A sub n is a specific number from the sequence, right? Incredibly enough, S sub n is the sum of the first this many. How we doing? So how did we do this? Where did we get the 101 from? We did A1 plus what's the last one going to be? The nth term, right? So the first term plus the last term. So the first term plus the last term. So if I add the first and the last one together, that's going to be the repeated sum. That's the thing that as I step in, it's going to get repeated. Why did you guys say that it was repeated 50 times?
Because there's a difference.
There's 100 numbers, right? N, cut in half because you're pairing them up. That's the formula. So any arithmetic sequence, even this weird dude here, if you want to know the sum of the first 50, let's try it out. So if I took this sequence here, I want to know what the sum of the first 50 numbers are. So what's n? 50, right? Because I want the first 50 numbers. 50 divided by 2. What's A1? 27. Oh, I should have said, let's do 51 because we already got the work done. You guys see what I need next, though, for... let's do 51. Is that cool? Because we actually already did the work here.
Yeah.
What's the 51st term? It's negative 373. Do you guys see that? What does this need? The first term plus the last term. So it's a two-step process. You actually have to first find the last term, and then you can plug it into this equation. So if I go 51 terms, we already did that work.
Yeah.
The first term is 27. The last term in the first 51 are negative 373. Somebody help me out. What is that?
346.
Oh, well, okay. Negative 346, yep.
So 51 divided by 2 would be like, what, 24.5?
Okay.
Divided by negative 346?
Yep.